Hello, welcome to the video on polynomial division. This is going to be a lesson on this topic, and we're going to be covering a good amount of material here. So let's go ahead and get started. So our objectives are going to be, we're going to learn how to divide polynomials using something called long division. And then we're going to use another technique in certain cases when we're dividing polynomials, and that's called synthetic division. And then I really want to make sure you understand the value and some of the applications you're going to be using polynomial division. And there's a ton, so you really have to commit to mastering this skill. But I want to take you back a few years to fourth grade, third grade, or whenever it was when you did a problem like this. Okay, so here we have 143 divided by 3. Now, imagine you were tutoring a younger brother or sister or somebody who's just learning division for the first time. How would you explain to them to do this particular problem? Okay? Well, you'd probably do something like this. You'd say, okay, 3 can't go into 1, but 3 can go into 14. Let's see here, 4 times. So 4 times 3 is 12. And we'll subtract 12 from 14. And that will be 2. 3 can't go into 2, but 3, we have to drop this 3 down. 3 can go into 23. Let's see here, 7 times 3, 21. And then we have a remainder of 2. Now, imagine the person receiving that explanation. They may very well be like saying to themselves, well, what exactly did you say? Could you slow down? Could you show me more examples? Division, you may not remember it exactly when someone shows you the very first time, but it's kind of an abstract concept initially. And same thing might occur with you when we're looking at polynomial division. The good news is that you already have an understanding of this process. This is called the division algorithm. And the steps that we're taking here to divide is going to be very similar to what we're going to be doing with long division, polynomial long division. Let's take a look at that now. So I'll try not to, I'll try my best to explain everything in a clear, upward manner. But just like, the first time you may have saw that the division problem we just looked at, it's going to take some practice. So if you don't get it initially, if you're not quite grasping the concepts, don't worry about it. Focus on the procedure first. And then as you do more of these, I think it all kind of sink in. All right. So here I have a problem. I'm going to divide x squared minus 4x plus 5, and I'm going to divide it by another polynomial, x plus 2. Okay, so this is a setup for a polynomial division problem. Okay, and I'm going to use a technique called long division. And when we use long division, we have this kind of divisor bar just like this. And I'm going to go ahead and start explaining the steps. Once again, don't question, why, more like the why. Just question, just remember the procedure, write it down, or maybe just watch it the first time out. Okay, so here it goes. So the first thing we need to do is we're going to be focusing on this part of the divisor. Okay, x plus 2 is called the divisor, and we're going to always be focusing in on the first term. In this case, it's going to be the x. And what we need to ask ourselves is, what do we need to multiply this x by to get to this x squared? Okay, this first term here. Okay, so what do I need to multiply this x by to get to x squared? What do you think about that for a second? You can see here I have a lot of the work already kind of written out for us. Well, the obvious answer is we need to multiply x, this x right here, by x. Okay, because x times x is, of course, x squared. So knowing that we need to multiply by x, here's what we're going to do. Okay, we're going to take that x, that's what we need to multiply to get x squared, and we're going to multiply by the entire divisor, okay, which is x plus 2, this entire part right here. Okay, so x is what we needed to get to x squared, so let's multiply it by x plus 2, the entire divisor, excuse me, and we get x squared plus 2x. Okay, and let's just make sure you understand what just happened here. The question is, we're going to look at this term right there. that x. Okay? And we have to ask ourselves, what do I have to multiply this x here to get an x squared? So the answer was x. Okay, because x times x is, of course, x squared. So I'm going to write that x right there. Okay, this is the x that we're talking about. Now, what we're going to do with that x is we're going to multiply it by this x plus 2. All right, and that's this work right here. So we did x times x plus 2, and you get x squared plus 2x. So if you understand that, then you're pretty well into being able to do this entire problem. So what we're going to do with this x squared plus 2x is we're going to subtract it from x squared minus 4x plus 5. And when we do that, the way we do that is this. Okay, we have x squared plus 2x, and I want to subtract it from x squared minus 4x plus 5. So I'm going to subtract it. Okay, subtract that entire quantity, x squared plus 2x. So my negative sign, or my subtraction sign, is outside of the parentheses here. But of course, really, that negative sign I can distribute, and you want to distribute to both x squared and a positive 2x. Okay, and when you do that, you're going to get this, minus x squared minus 2x. All right, so here you know why we got that x. Okay, right there. This is where we're at so far in our long division process. You know why we got that x. That was the x we needed to get to x squared. And now we're subtracting this x squared minus 2x, and you know why we got that, from x squared minus 4x plus 5. Now, when we subtract, okay, after we distribute our negative sign, we're going to add down in a column form. Okay, so x squared plus a negative x squared is 0. Negative 4x plus a negative 2x is a negative 6x. And then 5 plus nothing is a positive 5. So that's where we're at right now. Okay, so if you're with me at this stage of the game, then congratulations. I think you're doing just fine, because this is pretty much the entire process. What we're going to be doing now to finish this problem up is kind of repeating what we just did. All right, now instead of looking at this x squared and x like we did in the beginning of the problem, what we're going to focus on now to continue is we're going to look at this negative 6x and x. We have to ask ourselves, what do I need to multiply this x here to get to negative 6x? All right, and the answer is clearly a negative 6. Negative 6 times x is negative 6x, right? Okay, this is the negative 6x that we're trying to get to. So we're going to repeat what we just did. We're going to take a negative 6, we're going to multiply it by the entire divisor, which is x plus 2, and we get negative 6x minus 12. All right, and we're going to subtract this negative 6x minus 12 from minus 6x plus 5. Okay, so this is where we left off. All right, we have the negative 6. That's how we get our negative 6x. We're going to distribute by the entire divisor, negative 6x, negative 6 times x plus 2, and we get negative 6x minus 12. So at this point, we're going to subtract. Okay, we're going to subtract this negative 6x minus 12 from negative 6x plus 5, and we're going to get, let's just do it here. This is going to become a positive 6x, right? And this is also going to become a positive 12. Okay. Now let's go ahead and add down in the column form. And let's see here, negative 6x plus 6x is 0, and 5 plus 12 is 17. All right, so the answer here is x minus 6, and we have a remainder of 17. All right, so basically that's it. That's long division. Now, I'm almost positive, even for myself, if somebody explained this to me the first time out, that's a lot to take in. You might want to rewind the video, take a look at this and just go step by step. Give yourself the time to, really kind of comprehend what just happened here. Okay, first time is the most difficult, but if you take a look at the process, and we're going to be doing many example problems, you'll pick it up, guaranteed. All right, let's move on. I have another problem right here, and this is another long division problem. You might want to see if you can figure out the steps. But the point I want to make here is we have our divisor. Okay, the divisor is this part of the problem. Okay, it's what we're going to be dividing by. Okay, the dividend is what we're going to be dividing into. Okay, so this is the dividend, this 2x cubed minus x squared plus 6x minus 1. And this x squared minus 3x is called the divisor. And you can kind of see how I have it written right here. But in this particular process, you can see this problem, its answer is 2x plus 5. I'm not going to go through and explain exactly how we got to that answer. Most of the work is done here, but it's long division. And if you understood the last problem, you should be able to get this one correct. But what I do want to demonstrate is how we write our answers. This is the remainder here, 21x minus 1. So we don't write remainder 21x minus 1. The way we write that is the following. We write our answer. Okay, our answer is called the quotient. That's the result of doing division. And when you have a remainder with long division, you're going to put a plus sign. You're going to put the remainder, and you're going to put that over the divisor. Okay, so you want to go ahead and keep this particular format in mind. Okay, the quotient plus the remainder over the divisor. Okay, so commit that to memory, because that's the proper format of our of writing the result of doing a polynomial long division problem. Okay, let's move on. Now, we like shortcuts, and I particularly love this shortcut. It's synthetic division. I don't particularly like polynomial long division, because it's long and tedious and there's a lot of work to it. But we have to be able to divide polynomials. And when we are lucky enough where our divisor is in a form of x minus k or x minus a number k, okay, we can use something called synthetic division. You really want to pay attention to this, okay, because this is going to save you a ton of work. Okay, so let's just make sure we understand what this what I'm getting at here. So x minus k means when the divisor is something like this, x minus a number or x plus a number. Okay, so for example, x minus 2, the k is 2. Okay, so we're going to be dividing by a 2 here, and I'm going to show you how that works. Okay, this is where this 2 is, x minus k, all right, x minus 2 in this example. We're going to be using it in part of our procedure here in a second. Okay, this also is either x minus k or x plus k. Let me show you what I mean by that. So x plus a number, let's say x plus 5, right? You're saying, well, that's not x minus a number, but really you can rewrite it that way. You could say it's x minus a negative 5, right? So x minus a negative 5 is the same thing as x plus 5. Okay, so in this case, our k would be negative 5. All right? So let's take a look at this problem. So let's say we wanted to divide x squared minus 4x plus 5 by x minus 2. Okay, now of course we can use long division, what we just learned. However, anytime you have x minus or plus a number, we want to use synthetic division. Okay, so how does it work? And we go ahead and show you. All right, so the first thing you're going to do is you're going to put your k number. Okay, so here in this case it's 2. So you're going to write 2 right there. Okay, and you're going to draw yourself kind of like a backwards L. And then right here I have 1, negative 4, and 5. And what that is the coefficients of this polynomial here. So 1x squared, so I have 1, minus 4x, this minus 4 is here. Then I have a positive 5, and I write that right there. Okay, so here is the procedure. First thing you do is you drop down this number right here, 1. Okay, the very first coefficient, you drop it down right down underneath this this backwards L. And now you're going to go 2 times 1 is what? It's 2. You're going to write your answer in the next column. Then you're going to add down. So negative 4 plus 2 is what? It's negative 2. Okay, and now we're going to repeat the same thing. So then we're going to go 2, okay, this 2 right here, times negative 2 is what? 2 times negative 2 is negative 4. Okay, and we're going to write it in the next column, and then we're going to add down. Okay, so we get 5 plus negative 4, and that is 1. And now we're done. Okay, so what does this answer mean? You just did synthetic division here. Answer means this. This was x squared, right? 1x squared. This is minus 4x, and this was just a number, 5. Well, the result of synthetic division, when we look at our answers underneath here, the 1, the negative 2, and the 1, they're always one less power than this the coefficient. So here we had the 1x squared. Okay, well, we start off here. This is the 1x squared column. So right here, this represents a 1x. This is x, so 1 less power is just going to be a number. So this is 1x minus 2. Okay, the x gets down, drops away, and our remainder is 1. So we have a remainder equal to 1. So the result of x squared minus 4x plus 5, okay, we divided that by x minus 2. The answer is x minus 2, remainder 1. And of course, we'd write that plus 1 over the divisor, x minus 2. Okay, we're going to do many examples. We're going to practice synthetic division a lot, but it is a tremendous shortcut. You really want to keep that in mind. Now, one thing about synthetic division is that when we do synthetic division, we have to make sure all powers are represented. And for example, here I have a polynomial, and I want to divide it by another polynomial. So I have 6x to the 4th plus 3x squared minus x plus 5. If you notice here, there isn't an x cubed term. So if I was to set this up using long division, I'd have my long division bar like so. I'd have x plus 2 right here. And being that I'm not going to be using long division, and why am I not going to be using long division, by the way? Okay, I'm not going to be using long division because I'm going to take advantage of the fact that I have x plus a number or x minus a number, okay, as my divisor. So I'm going to be using synthetic division. But when I use synthetic division, I have to represent those missing powers. So in other words, we didn't have this x cubed term, so I have to write in a 0 x cubed. Okay, so, and by the way, these polynomials all have to be in standard form from highest to lowest power. So I have 6x to the 4th plus 0x cubed plus 3x squared minus a 1x plus 5. Okay, and now I had this x plus 2, but we talked about it. It's going to be x minus a number. So x minus a minus 2 is the same thing as x plus 2. So my k value is negative 2. All right, so let's set this up for synthetic division. I have negative 2, that's my k. 6 represents my the coefficient, first coefficient of the polynomial. I have 0, okay, so I have a 0 right there. 3, 3, negative 1, 5, and 5. And of course, I have my nice little backwards L here. And now, let's go ahead and start our synthetic division process. Okay, the first thing we're going to do is take that first number. Okay, we drop it down, just like so. Now, it's going to be negative 2 times 6 is negative 12. Okay, remember I write the answer, okay, in the next column over. Then I add. 0 plus negative 12 is negative 12. Now I'm going to take that negative 2, multiply it by negative 12. So I get what? Negative 2 times negative 12 is a positive 24. I'm going to add down again. 3 plus 24 is 27. I'm going to take negative 2, multiply it by a positive 27. So if you need to do that over here, I could do things by hand. Let's see, I get 14. So that's going to be 54. So that's going to be negative 54. Okay, that's the result. Negative 2 times 27 is negative 54. Add down, I get negative 1 plus negative 54. It's negative 55. So 55 times 2. All right, so of course that is going to be 110. All right. And let's write that right there. That's a negative and a negative, by the way. And we add down. So let's just make sure I'm not messing up. I had negative 1 plus negative 54 was negative 55. Negative 2 times negative 55 was a positive 110. Okay, so I'm writing that answer there, and I'm going to add down, and I get 115. All right. So being at this 6 was this is the x fourth column, x cubed, x squared, x in number. Our answer is going to be 6x cubed. Okay, it's 1 degree less, minus 12x squared plus 27x minus 55, and 115 is our remainder. So we can write that as plus 115 over x plus 2, right? That's our divisor. Okay, so there you go. That is synthetic division. Now, why is this important? You're going to see here that what we're going to be able to do with polynomial division is we have this particular polynomial function, for example. We're going to be able to evaluate this polynomial for different values and in a different manner than we're used to doing. Okay, and which I think is a really nice shortcut manner, but it's very powerful. So you'll see how that works here in future videos. Also, polynomial division is going to help us factor these type of polynomials, and of course, polynomial division, I think its most powerful application is to help us find the roots, zeros, solve a polynomial equation. All right, so many applications, and there's just no getting around it. You have to master this. So watch the lesson again and make sure you do those example problems. Let's go and wrap this up. Okay, so polynomial division follows the same steps, pretty close as we saw as our first numeric division problem. Okay, it follows very similar steps as that division algorithm. Long division works with any polynomial problem. Okay, I want to make sure you understand that. When you don't have that x minus k situation, well, guess what? You're going to have to enjoy doing long division. However, when you do have x minus number or x plus a number, we want to use synthetic division. Okay, and when you're doing that, if you have a missing power, as we saw in that previous problem, you're going to have to put in a 0 for that missing power when you use synthetic division. And last but not least, polynomial division is very powerful. Okay, so make sure you master this, and you'll appreciate this later. It's like a lot of things. In the beginning, you're not quite sure. You learn how to do it, you practice it, and then you can reflect back and say, wow, that was really powerful. Okay, so keep working hard. Good luck. Don't be discouraged. This is a little bit awkward the first time out, but I'm confident that you're going to be able to be a master of this. You just have to work at a little bit. You might have to work at a little bit more harder because it is a little bit complex in the beginning. Okay, good luck.